So this video will be our next two types of reaction, a single replacement reaction and a double replacement reaction. So if we'll notice a single, notice that A here is by itself. So you always start out with a single element. The A could be here. I just want you to know that it could be here. So on this side, there's an element that is single, and then you've got a compound. So it's an element plus a compound or a compound plus an element. If you'll notice what's happening, A in this instance is kicking B out. B is now single, and A and C are together. So we've got this single replacement. This is sometimes called a single displacement. So if you like the word displacement, you can use that. So single replacement or single displacement. So how are you going to know what gets displaced or replaced in a reaction? So notice in this first example, you've got potassium, which is the single element, and you've got the compound of aluminum chloride. How are you going to know what to put back together and what gets what I call kicked out? It depends on what this is. If this is a metal, it is going to replace the metal in the compound. So basically the aluminum and the potassium are going to switch places is what's going to happen. So down here in our second example that we've got here, you've got magnesium oxide. So this is our compound. Chlorine is our single element. Chlorine is a non-metal, so the non-metal is going to replace the non-metal portion of the compound. So chlorine is going to kick out the oxygen. So how are you going to know what gets kicked out by itself? Depends on what started out as a single. So potassium is going to kick out aluminum. So first blank is always for words. So we're going to write aluminum. That's the one that now is going to be single. And we're going to put a plus. The new compound is now potassium. And the potassium is going to be bonded with the chloride. Does that make sense? Hope so. So coming down on this one, you've got magnesium oxide and chlorine. So the element that's going to get kicked out or by itself is now going to be the oxygen, because this is a non-metal. Non-metals kick out the other or replace the other. And then our new compound is always written metal, non-metal. So magnesium is always written first. Metal is now going to be combined or bonded with chlorine, which is now going to be called chloride because now it's part of a compound. Okay, we see this with ionic compounds, so these are all going to be ionic. So single replacement, an element starts single and a different element ends single. An element starts single, a different element, so that's a single replacement. It is going to be a redox. Let's show you why. This is a pure element, so we'll do pure element is starting out as 0. Aluminum over here is also a pure element. So I'm going to go ahead and put zeros under my pure elements. Let's look here. My pure element is chlorine, oxygen. So we'll go ahead and do that. I would suggest you do that first. Okay. And then we've got a compound. It's an ionic compound. So this is a 3 plus and this is a 1 minus. Over here, this is a 1 plus and a 1 minus. So if you'll notice, the thing that stayed as a compound, in this instance being the chloride never changed being -1. It was always bonded to something. So the things involved in the redox, so yes, it is a redox, are going to be your metals that did the switching places. So notice the potassium, it went from a 0 to a +1. Started at a 0, went to a +1. So potassium went up. Went from 0 to a +1. So if it went up, it is the oxidized. It is the element that was oxidized. Notice this. This ion, 3 plus, went to a 0. Can you see that? I didn't draw my arrow on the other one, but 3 plus to a 0, it's gone down. So the aluminum ion is what's going down. That's what's been reduced. So this was the element form, that's the ion form. So yes, redox. Let's go down and answer this one. This is a compound, so this is a 2 plus. That's a 2 minus, periodic table. We already said our elements are 0. This is a compound, so this is a 2 plus. This is a 1 minus. So can you see this time the magnesium didn't change because it was always part of the compound, but the ones that switch places are the one that's getting involved here. So let's look at what's happening to oxygen. Oxygen went from a -2 to a 0. So it actually went up. You were in the negative and now you're at 0. So it is the oxygen ion, not the element. So it's not O2, it's the ion. Okay, there's a difference between the element and the ion. The ion became reduced, and look here. This is chlorine, the element. So the element actually went down a number, and chlorine element is diatomic, so it's Cl2. A lot of times in just Gen Chem, I'm happy if you get the letters in there right. So just say on that, I'm usually kind of just happy with the letters being right. All right, so we're going to go up here and we're going to balance this. So we got potassium, which is K. Aluminum chloride, ionic compound, so we're going to switch them. You put my blanks in there. Yields a blank. Aluminum's just Al, no charge. And potassium, +1, -1, just that. So we got to write those formulas correctly. So now we're going to list our elements. And notice these are in different order, but I'm going to put them in the same order that I just wrote those so I can keep track. And again, you don't need to do this if you're good at balancing. All right, we're going to count 1 of those, 1 of those, 3 of those, 1 of those, 1 of those, 1 of those. So the element that's messed up is the chlorine. The chlorine needs to get ×3. So that ×3, I need to find where chlorine is. So what else is getting ×3? That potassium is getting ×3. So I need to come over here and do ×3. So I need to put a 3 there. 3, 3, 1, 1, 3, 3. So these will just become 1s. Balanced equation. Balancing just takes some practice, and some of you need more practice than others. So if you want an extra worksheet on balancing, I have it. Okay. All right. What happens when they're both 2s? If they're both 2s, they cancel each other out. We don't write them if they're both 2s. It just becomes MgO. Now, chlorine, unfortunately, is one of those 7 that when they're by themselves, they do get a 2. Oxygen, when it's by itself, it does get a 2. And then magnesium chloride, MgCl2. All right. Swap and drop. Let's make our list. We got magnesium. We've got oxygen, chlorine, magnesium, oxygen, chlorine. We've got 1 of those, 1 of those, 2 of those. We've got 1 of those, 2 of those, 2 of those. We pick an element to fix. The only one messed up is my oxygen, so I'm going to go ×2. Alrighty, so did we fix it? Well, nope, because this also gets ×2. Do you see it's in front of the compound? So now I got to come over here and I've got to do ×2 to fix that magnesium. But now that went in front of both of those. Let me go ahead and do that. So now chlorine has gone to a 4 on me. How can I fix that? Well, ×2. Now that is 4. This doesn't need to get anything, so it's 1. So this is a 2, 4. I think I messed up. I do believe I see that. Hopefully you guys caught that. I totally see that. It's like, there's no way that's right. My dot is very big. So let me fix that. That should be a 2 there. So there's 2 magnesiums, 2 oxygens, there's 2 oxygens, 4 chlorines, 2 magnesiums. Now we're good. So what I did wrong was I put this number in there. Nope, this is the number that goes in the blank. Common mistake with students, by the way. I was just getting in a hurry. All right, since we're at the 10-minute mark, we're going to go ahead and stop this video, and we will do double displacement in a separate video. See you on the double displacement video.